Redox reactions are another way to say oxidation-reduction reactions. Redox reactions are reactions in which electrons are transferred. In an oxidation-reduction reaction or a redox reaction, there's an oxidation portion and a reduction portion of the reaction. We can think of these as two halves of the reaction because an electron is transferred from one chemical species to another. So a redox reaction is a reaction where electrons are transferred, and we can actually kind of keep track of who's transferring it to whom, if you will. So let's look at an example and talk about the vocabulary. Sodium metal will react with chlorine gas to form sodium chloride. Sodium chloride is an ionic compound, and to balance this chemical reaction I need two NaCl's because of the two chlorines, which means I need two sodiums. I only have one chlorine, but I don't have to write the one. This reaction happens because neutral atoms of sodium and chlorine become ions. In sodium chloride, they are actually ions. Now, we don't write their ionic charges here because combined, their charges balance each other. Sometimes we say the charges cancel each other, but the charges are still there. They're just balanced, so we don't write them. So let's look at the two halves of this reaction as it proceeds. In one half, I have a neutral sodium atom going to form the sodium ion, and of course you remember that the sodium ion is +1. In order to form the +1 ion, what has to happen is sodium has to lose an electron. Sodium doesn't actually lose an electron, it's not lost, he gives it away. So an electron is also one of the products of this reaction. The chlorine, which is Cl2 because it's diatomic, forms the chloride ion, the Cl-. Now in order for chlorine to form a Cl-, it has to gain an electron. That electron is not gained out of thin air, it has to come from somebody, and by now I think you can see it comes from the sodium. So he has to combine with an electron to form the Cl-. And of course to balance this, I need two Cl- because two chloride ions will actually be formed from the two chlorine atoms, and I need two electrons to cause this transfer. Now if I look at these two half reactions together, they make up this reaction, but in order for chlorine to get his two electrons, sodium has to give away two electrons, which means I'm going to need two sodiums. And this is how we balance it. We see the two sodiums giving me the two sodium ions and the two chloride ions, as well as the Cl2. These two half reactions, again, we do call them half reactions. They give us the oxidation portion and the reduction portion. The oxidation half reaction is the half reaction in which electrons are lost. Again, they're not really lost, but we can phrase it that way. The reduction half reaction is the half reaction in which electrons are gained. There's a mnemonic device to help you remember that. It is oil rig. The oxidation loses electrons, the reduction gains electrons. A second mnemonic device, which is a little more fun, is Leo goes grr. The loss of electrons is the oxidation. The gain of electrons, I guess we could say grr. The gain of electrons is the reduction. So anyway, however you want to think of it, the oxidation half reaction is where the half reaction where the electrons are lost. So this one is the oxidation half reaction. And the reduction half reaction is where the electrons are gained. This one is the reduction half reaction. In the same vein, we can label the reacting species. We'll always go to the reactants, and we would say that sodium is oxidized. He is oxidized to form the sodium +1. Similarly, we can say that chlorine is reduced. So Cl2, which is the elemental form of chlorine, is reduced because he is the reduction half reaction. One more set of words to apply to this. As I look at a balanced redox reaction, once I identify who has been oxidized, like the sodium has been oxidized, I could now call him the reducing agent. When I label somebody an agent, this is someone who causes something else to happen. So sodium causes the chlorine to be reduced because chlorine is reduced. I also can label chlorine as the oxidizing agent because, again, he causes the sodium to be oxidized. So that's the vocabulary associated with a redox reaction. If you can follow the path of the electrons and decide who's gained the electrons and who's reduced and who's lost the electrons, you can label who's been oxidized and reduced, who's the reducing agent and the oxidizing agent.